Good morning and welcome to our second webinar on BIM for building product manufacturers. My name is Phil Marshall and this webinar is one in a series offered by MicroCAD on the use of Autodesk tools and data platform to enable manufacturers to collaborate with architects, builders, and other partners in the building project. The first webinar last week focused on the business needs and workflows associated with sharing data. In our webinar today, we'll look at the technical details of sharing data. As a company, MicroCAD empowers design professionals in the construction and manufacturing industries to increase productivity and meet project goals. With 30 years of experience as a minority-owned business, we pride ourselves on working with clients through every stage of the design process to assess needs and provide tailored and effective solutions. Today, we are focusing on the detailed functionality to enable design collaboration. Design collaboration is where multiple people can participate in the design process and share information synchronously. This is clearly where the biggest benefits of BIM are. Autodesk has taken this concept and put it on the cloud. This webinar is intended to show how building product manufacturers can share data with architects. We will demonstrate the software's functionality using simplified models so you can focus on the process. The Autodesk product highlighted here is Inventor, a full-function CAD/CAM system for product design and manufacturing. We will show the interoperability with Revit, an architectural BIM modeling system, and we will show BIM360, a cloud-based data platform which enables data sharing. As we go through the webinar, you may have questions or comments. Feel free to enter them into the questions area of the interface on the right-hand side. If you don't see the control panel, click on the orange arrow. I will try to respond as I see the questions. One other point, the excitement of BIM extends to all of the partners in the building project. This webinar focuses on the manufacturers, but everybody benefits. We will offer other BIM 360 webinars in the future and expand them to cover all the potential users. The intended audience of this webinar is the building product manufacturers, you. This applies to both vertical and horizontal construction endeavors, architectural, civil, plant engineering. Projects are getting more complicated, the use of modular design is increasing. More and more building products are made in a factory environment and not at the job site. And the project team is more and more using BIM or building information management to collaborate. So what does this mean to you? The architect may have one idea of what, say, a railing system should look like for his building. He would then search catalogs for a matching railing. If there is a close match but not exact, the architect defines his unique requirements and loads those into the BIM model. The manufacturer of the railing system would consider the architect's unique requirements and cost out custom products. They would then have to plan the manufacturing process and raw materials for that product. They add information to the BIM model reflecting their progress. When the finished railing gets to the job site, the construction workers need to install it using information from both the architect and manufacturer. Where do they get that data? The BIM model. What's the common thread here? It's the data. Each of the partners in the project needs information from the others and generates more information internally. But each cares about different things. The architect is concerned about how it looks. The manufacturer is concerned about the details of how it's built. The construction team is concerned about how it's attached, and each uses a different tool. The architect probably uses Revit. The manufacturer uses some mechanical design software like SolidWorks, CATIA, Creo, or Autodesk's own Inventor. And the contractor just wants to look at the model and the drawings. In the past, 2D drawings were used to exchange this data, but this is a slow, incomplete, error-prone approach. With BIM, all partners can use 3D intelligent models, but we have to provide interoperability amongst all the players. What we're talking about today is how the manufacturer can easily make the data from the architect's BIM model available to their internal CAD/CAM systems, and just as importantly, handle the inevitable changes. So what kind of building products are we talking about here? There's a large number of things like stairs, escalators, elevators, conveyors, doors, windows, window systems, concrete precasts, concrete pre-stressed, metal or wood frame door panels, curtain wall systems, wall cladding, both interior and exterior, sunshades, and so on. Each of more and more of the final building is fabricated off-site and delivered as a module, and each of these products has the same data sharing requirements. Okay, so how can you actually share the data? There are 3 potential workflows depending on the type of products you make. 1, if you're making standard parts, taking advantage of manufacturing efficiencies of scale, then you would publish a catalog and have an architect select products from that catalog. Your design and manufacturing processes don't need any input from the architect. 2, if you are primarily making configurable products, that is, standard components can be combined or altered in some way, then you need to work with the architects on the particular configuration they need. Starting from your standard assemblies, they might introduce minor design changes to meet the project requirements. This is a lot of back and forth data exchange. 3, if you're delivering custom products defined by the architect, then the source of the design is the architect, and your job is to determine the manufacturing process. Of course, a good architect would always be open to suggestions to improve the product and make it less expensive to manufacture. Therefore, some interaction and bidirectional data flow is necessary. We can summarize the data flow needs of all 3 of these approaches by talking about data that flows from the manufacturer to the architect and data that flows from the architect to the manufacturer. So today we'll be showing you each of those processes. In the catalog workflow approach, the standard component approach this is the easiest workflow. The manufacturer designs a component in their favorite 3D mechanical design software. Of course, we think it's best if it's Inventor, but even if it isn't, Inventor can use associative links to other mechanical CAD systems. CAM output can come from this design, either from the original CAD system or Inventor. In Inventor, the model can be simplified because the architect doesn't need or want excessive detail, and defining parameters can be added. This is then output and published as a Revit model family to make it easy for the architect to use. These Revit families can be included in an online catalog. Here, there isn't any data flow from the architect. It's solely from the manufacturer to the architect. Let's look at the catalog workflow in the software. Here, we're creating the model in Inventor and need to make it available to the architect in Revit. There we go. So here we're in Inventor. And we see a sunshade assembly. Although we're only using Inventor as a mechanical design software today, we could have started with other systems like Creo, CATIA, or SolidWorks, because in Inventor, we can open native files from any of those CAD systems. So if we look at supported file formats, we see CATIA, Pro Engineer, Solid Edge, SolidWorks, even Rhino. So we can bring the model in from any of these CAD systems. If we look at this model, we see it has manufacturing details like brackets and mounting bolts that the architect probably is not interested in. So we'll have to simplify it before we send it to the architect. From these, and if we look at the drawings, we see even more manufacturing information, parts list, and fabrication and assembly details, which the architect certainly has no interest. From these models, the manufacturer, however, can create the CNC tool paths for cutting out the oval openings on the side piece, or creating CNC for any other machine operation in the shop. Unfolding of sheet metal, nesting, and then laser or water jet cutting can also be done with Inventor. Okay, let's go back to the design. We need to share this model so that the architect can easily include our design in her building. In Inventor, there's the ability to directly create a Revit family. But first, we should simplify it. The Shrinkwrap function allows you to create a single part from a complex assembly. There are several reasons why you'd want to do that. First, the manufacturing model is typically way too detailed for the architect. Making a Revit family with all of that detail would create an overweight, bloated object, which would impact the performance of the BIM model. Second, you may have proprietary or intellectual property in your model that you don't want to share with others. And third, by keeping the manufacturing specific details in-house, you can optimize your internal process without having to coordinate with others. Okay, so in the Shrinkwrap dialog, you can exclude parts by size. So here, if we put 3 in this box, any parts that are small that fit in the 3 by 3 by 3 box are excluded. The brackets and the bolts are gone. And we can select parts to be excluded. So we pick the 2 mounting plates. So with this Shrinkwrap process, it replaces the assembly with a single part. The parts that we didn't want, the brackets and the bolts and the plates, are gone. And what was an assembly is now a part. That makes the Inventor model very lightweight. One more thing we should do is locate the origin. So we'll do that on the middle back. So here's a point that's going to be our origin point, the middle back of that sunshade, up against flush against the building wall. All right, so now we need to make a Revit family. So under the BIM content function, here's a whole set of tools to enable us to make Revit families. Now, if the product you are making is mechanical equipment like a pump or a chiller, then you need to provide information about how to hook it up. More than just the location of the connection, you can identify the size of the ductor pipe, the electrical load, and the flow rate. This information is then used in Revit for system sizing. Connectors are available for cable trays, conduit, duct, pipe, and electrical wiring. The UCS command lets us create the origin and orient the model consistent with the architectural model. When we're authoring building components, we can tell it what properties we want this component to have. So we certainly want to fill in things like the manufacturer, Acme sunshades, and the model number. But we may have some other model properties we want to show. And these would come directly from the Inventor physical model, things like weight, center of gravity, material, things like that, finish, because that might be important for the people in the field if they were erecting this. Remember that Revit is an intelligent system, so we can use all of this data in these properties for schedules and tags also. We also want to choose an Omni class number to indicate what kind of object this is. So here we're going to do 2330 6011 for an exterior protection of openings. And this Omni class is used in Revit to identify the different kinds of components that are in the building model. Once all of the intelligence of the components are set, then we can export it as a building model. And tell it where to put that family. And it creates the Revit family from the geometry and the components that are in the Inventor model. I always like to see this message, the operation completed successfully. And it creates a report that shows exactly what happened, what the source file was, what the target file was, and it created a family.rfa, the type of family, the size, information about this, and if this had connectors, information about the connectors, and information about the properties that came across. So this is a useful tool. All right, let's go to Revit now. And in Revit, let's see how we can use those families. So we'll switch to the Revit model, very simple building, and we're going to throw some sunshades over these windows over here. Go to a floor plan, and we're going to place a component. But we don't have that component in the model just yet, so we need to load a family, because this is a new family. This is the one we just created. And you can see this is the sunshade, and it behaves like any Revit family. We do want to put it in an elevation of 9.6 and centered on that window, centered on this window. And let's take a look. So there's our sunshades in here. Now, what we've done is we've taken the model from the Inventor mechanical design system, brought it very quickly into a Revit family, and allowed the architect to place it into their building. So this is linking inventors to the Revit model. But what happens about doing it the other way around? How about if we want to get information from the Revit model back to the Inventor model? So let's take a look at this sunshade over here. This is a case where the architect working in Revit wanted to show what they wanted for a sunshade in blocky form, but that's up to the manufacturer to provide the details. So here it's for some south-facing windows. The architect happened to use model in place functionality within Revit, but it could have been built using any Revit operation. We've given that shape to the manufacturer for detailing. So what the architect needs to do is to provide a view that shows just that one sunshade, because we don't have to send the entire building over to the mechanical design system. We just need to send that sunshade part. So we're going to create a brand new view. So we're going to duplicate, and we'll give it a name. Let's name it sunshades. And for this view, we'll use visibility graphics to display only the category specialty equipment, which is the category that we're using for all of the sunshades. So now we see we've got a bunch of sunshades here, but we don't want that one or these over here or these. So we're going to hide those in the view. So our view consists of just this one sunshade that the architect wants to send to the manufacturer. All right. So we save this, and let's go back to Inventor. So Inventor, we're going to build a new model. No, I'm sorry, we're going to open that Revit model. So it's here where we can specify what kind of files we're going to open. And Revit is one of the formats along with the other CAD systems here. So within here, we want, there was the model we're working with. So now it's accessing the Revit model, and we could convert the entire model to Inventor assemblies, but we don't need to. We're just going to reference it. That allows the architect to continue work and make changes as necessary. Here's the whole building. If we wanted to bring the whole building in, we could do that, but we don't really want to. We just want to bring in that one view called sunshades, and all that's in that view is that one sunshade. So now we have that sunshade model here. All right, we're going to build a sunshade around it. So very quickly, let's make a new part. We're going to call it end custom piece on that face. And for those who are used to working in Inventor, this should be a pretty straightforward process. We're going to take this, project the end of that shape that we got from the architect, and extrude it 1/2 inch to give it some thickness. And we're going to make this out of steel and paint it blue. So there's one end piece for this shape. And of course, it follows the shape exactly. Now we're going to take another one of these end pieces at the other end. And let's constrain it. And we'll constrain the edge. So now we have the two ends directly from the model provided by the architect. So it's about this time in the real world that you get a phone call or an email from the architect saying, oh, I've got a new idea. I want to try something different. Well, let's go back to the Revit model. Here we're in Inventor, and the architect may be looking at this model and decide, you know, this is kind of chunky. Let's make this a little bit narrower and a little bit longer. So let's stretch this out a bit because this looks more appealing, and then saves that file. So now what happened? I'll save. There we go. So what happened for the Inventor model? So in the Inventor model, we see that this update button has the lightning bolt on it. What that means is that Inventor recognizes that some of the geometry that this model uses is not up to date. So by clicking on this update button, it goes back to the source of the information and updates. So it makes it narrower and longer because that's what the architect wanted. Okay, let's finish up this model. So I don't need to see that anymore. We've got these two pieces. Let's throw some railings in there. So I think I've got some slats. And that slat needs to be a little bit longer. It's a 14-foot slat, not an 8-foot slat, so it's 14. And we're going to constrain it. A little bit to the front. And then we're going to pattern and get a bunch of these. Let's use 8 inches and see if we can get 6 of them. There we go. So now we've got a modeled sunshade, and let's shrink wrap that. Save it. And shrink wrap it. And we didn't add any of the manufacturing details, so we really don't need to remove anything. So we'll just shrink wrap it as is, and it turns it into a part rather than assembly. And then we'll go to the BIM content. Give it Acme sunshades again, because this is a new design, but this is totally custom. And export this. And we'll make a Revit family from this. Of course, what the manufacturer would be doing with this model would be to add all the manufacturing details going into the fixturing, the CNC tool paths as necessary for making this part. All right, so come back into Revit. And we're going to load that family that we just built. And let's look at the floor plan. That's the easiest way to put it. Set the elevation to 9.6. Set the elevation to 9. And then place this let's look at it in 3D. And it's in that same location as what the architect sketched. So what we'll do is we'll hide what the architect sketched. And we see our sunshade right with the same shape and the same position as the architect had. All right, so what we did is two things. We took information from the Inventor model used for manufacturing and sent it over to the architect so we could grab these standard components from a family and put them for the architect to put them in the building. The second process, we went from the architect's model where the architect sketched out something, took that information into Inventor, built an Inventor model, and then filtered it back to the architect as an architect's family, fully detailed for use in the final product. So we've gone in both directions, back and forth, and that could happen as much as necessary. So why have I been stressing Inventors? Because Inventor provides the out-of-the-box functionality that fits so well in the building product and fabrication workflows with BIM and Revit. Models built in Inventor can be transformed into Revit families, and Revit the Inventor models can contain the intelligence to let those families be used by Revit analysis tools. And because Inventor can link associatively with the Revit models, the geometry created by the architect can be used as part of the Inventor model. And it updates automatically when the architect updates the Revit model. So we see that Autodesk provides the workflows to exchange data amongst all the partners on the project, but what makes it particularly useful now is that all of the products support intelligent information in the cloud infrastructure provided by Autodesk, the BIM360 platform. This is especially important now that designers are working from home. Revit users can design with their models in the cloud, securely sharing the data with whomever they wish. Inventor users can access the same data, incorporating it into their designs. On the BIM360 data platform, the software keeps track of versions of the design and controls access. All users can view, mark up, create, or respond to issues, all without having either Revit or Inventor on their computer. And the access is using any device, laptop, tablet, or phone, and anywhere on the site, in the trailer, or in the office, or from home, anywhere there's an internet connection. Let's see what that might look like. So this is BIM360 running. You can have multiple projects, and in this project we have folders. You can build your own folder structure. So our folder structure is under this building products folder, and we have the building and some drawings. If we look at the drawings, these are the drawings that the manufacturer made available. And for any of these documents, we have redlining capability as well as issue tracking. So someone could say, I don't like this. There's a concern about whether this is going to be adequately mounted. Show me your calculations. And that becomes an issue, and it has to be handled. So all of the documentation is available, all of the drawings for the field. We also can see the architectural model. So in 3D, or all of the sheets that the architect created, you can work with this model to understand what the attachment points are, or what is going where exactly. So that enables you to share that information. Because it's all in the cloud, there's no sending of data from one person to another. It's just uploading this data and working with it in the cloud. And in this folder structure, you can set up access by folder, so only the people on the project have access to that particular set of data. So it's a secure way of controlling the information and sharing it with everyone else. So we have a single data platform for data, BIM360. We have the world's top software tool for BIM, that's Revit, and a world-class manufacturing mechanical design package called Inventor, all from Autodesk and MicroCAD. All right, before I catch up on the questions, let me mention that MicroCAD will be running more webinars about BIM and cloud services. Take this opportunity to tell us what topics you would be most interested in by entering them in the chat box. We really want to address your needs. Okay, on to the questions. Yeah, so there's a question, do I need both Revit and Inventor to do this? Well, if you're the product manufacturer, you don't absolutely need Revit because all of your work, your design work, all your authoring work is going to be done in Inventor. You're using Revit data and you're sending Revit files back to the architect, but you don't need Revit to do any authoring work. However, most of our users have a single seat of Revit to verify the models coming in from and going out to the architect. It's a pretty small price to pay to avoid mistakes or misunderstandings. And you don't need to become a Revit guru. You only need to understand how to, you won't be authoring anything in Revit. You just need to know how to find your way around Revit models and navigate those models. Yeah, someone said that they're using AutoCAD now and they're fine. They're moving 2D data back and forth. And if that's satisfactory for you, then I'm certainly not telling you what to change. A lot of people are using AutoCAD tied to some CAM processing, like laying outs of sheets on the punch press or any other manufacturing process. And if you've got that and it's working, the last thing I'd suggest is that you change it. However, I will stress that more and more architects are using BIM and using Revit for their data exchange, and they are requiring their partners on projects to be able to access Revit data. You can't access Revit data from AutoCAD. So you can use Inventor as the mechanism to get the Revit data in a format that you can use and use AutoCAD for your manufacturing in-house, but use Inventor as your translation device in order to mediate between the 3D model, 3D BIM model from Revit and what you're doing in-house for manufacturing. And someone else said that their products are a lot more complicated than what we're showing. Yeah, that I know real world, there's real complicated products, and what I just showed was a simplification, but I had half an hour, and what I wanted to do is to stress today the process, the idea that you can be doing your design work, your detailing work in Inventor, and take that part, simplify it for the architect and send it over as a family, and let the architect take that family and put it into their buildings. So yes, I use a very simplified model, but exactly the same process would happen for very complex escalators, for example, with tens of thousands of parts, as the assemblies we had that had half a dozen parts. So actually the benefits would be even greater for a complex assembly because there's no way the architect would be able to recreate the geometry of an escalator, not with enough information to enable them to place it and to work with it. But you can offer that to the architect for just about no effort at all because you've got all of that detail. You just get rid of the things that aren't important to the architect and give the architect a family that contains the things that are. All right, any more questions? Okay, doesn't seem like there's any more questions. So I want to thank you for taking the time today to attend today's webinar. I hope you found it useful. We'll be continuing this series of BIM webinars and adding new topics. Keep watching www.microcad3d.com as we add more webinars to this series. If you want more information, we'd love to talk to each of you and discuss how the tools we showed today could improve your productivity and smooth your workflows in the BIM project. So feel free to contact me directly or any of the MicroCAD offices. Thank you again, and this ends the webinar.